230 volt to 115 volt, then 1200 volt to 2400 volt. So there will be many different types. More than this, many different type of transformers are also there. So next topic is cooling methods of transform. Why we are studying all these things before we are refreshing all these things? Because while designing a transformer, the engineer should know very thorough. He must have a thorough idea about the transformer construction. What are the methods of cooling? All these things must be familiar with the design engineer. So we can't say any transformer as what ideal transformer, and we know the meaning for what ideal transformer, because ideal transformer is the transformer which doesn't have any losses. So practically that ideal transformer is possible only theoretically. Practically it is not at all possible. So the losses developed in the transformer, so most of these losses will be get converted into thermal energy that causes heating of corresponding transformer part. And this heat dissipation in transformer occurs by three things, that is conduction, convection and radiation. So this is what shown: conduction, convection and radiation. And the parts of the heat flow will be very different things, that is from the internal most heated parts of a given part of the machine, that means either core or winding, to their outer surface of the contact. Then from the outer surface, second thing is from the outer surface of the transformer part to the oil which cools the transformer. Then from oil to the walls of the cooler, then from the walls of the cooler to the cooling medium. So these are the different paths in which the heat flow will be taking place. The first one is from the internal most heated spot of a given part to their outer surface in contact with the oil. Second one is from the outer surface of a transformer part to the oil which cools it, then from the oil to the walls of the cooler, then from the walls of the cooler to the cooling medium. The next one is different methods of cooling method. So the different methods of cooling are air natural, air blast, then for oil immersed transformer, oil natural, air natural, then oil natural, air forced, oil forced and air forced, then oil forced and water forced. So these are the different types of transformers which is available. So first of all we need to know about what air natural and air blast transformers. So this air natural transformer is otherwise called as what self air cooled transformer, and this method of transformer cooling is generally used in smaller type of transformers, that is up to 3 MVA capacity. And in this method the transformer is allowed to cool by the natural air flow which is surrounding the transformer. So second thing is air blast transformer. So the transformers rated more than 3 MVA, the cooling by natural air method is inadequate. So it will not be sufficient. In this method, air is forced on the core and the winding with the help of either a fan or blowers. So the air supply must be filtered to prevent the accumulation of dust particle through this ventilation ducts. And usually this method of cooling can be used for the transformers up to 15 MVA. So if it goes beyond 15 MVA, then we need to go for other type of transformers. So next one is oil natural and air natural cooling. See the diagram itself, it is showing it will be having some cooling tubes outside that thing, but there will be no any other mechanism involved in this cooling. So in this method, the heat generated in the core and the winding is directly transferred to the oil, and according to the principle of convection, the heated oil flows in the upward direction and through the radiator also. The vacant places will be filled by the cooled oil from the radiator, and the heat from the oil will dissipate in the atmosphere due to the natural airflow across the transformer. Okay, so in this way the oil in the transformer keeps circulating due to natural convection, and the dissipating heat in the atmosphere due to natural conduction. And transformers this type of cooling can be used up to 30 MVA transformers. Okay, so next one is oil oil natural and air forced. So here the oil will be a natural and the air will be forcibly done by some mechanism, either it may be a fan or some mechanism. So here the heat dissipation can be improved little by applying force on the air in the dissipating area, heat dissipating surface. So the forced air provides faster heat dissipation than natural flow. Usually if you want to cool the hot water, what we used to do, we used to keep near to the ceiling fan. In the same way, here a separate fan will be provided. See here, a fan will be provided like this. So here the fans are mounted near the radiator, and it may be provided with an automatic starting arrangement which turns on when the temperature increases beyond a certain value, and it will be automatically get turned off when the temperature goes below the certain value. And this transformer cooling method is generally used for large transformers that rating may be up from 31 MVA to 60 MVA. Next we will see about what oil forced air forced cooling of transformer. So in this method the oil is circulated with the help of a pump. See here, the winding, everything will be there. In the winding only the heat will be produced. That heat will be transferred to this oil which is surrounding this tank, and this oil will be pumped from the tank to the radiator. Okay, and this oil is circulated with the help of this pump, and this it will be exchanged through heat exchangers. So here there will be a fan. Here there is a fan, and this fan will continuously running, or it may be running based upon the temperature. And here the compressed air is forced to flow on the heat exchanger with the help of this fan, and the heat exchangers may be mounted separately from the transformer tank. See here, this is the transformer tank, and this radiator is mounted separately, and it will be connected through the pipes. And this type of cooling is provided for very higher rating of transformers which is at substations or the generating stations. So next thing is oil forced water forced cooling of transformer. So this method is very similar to what oil forced and air forced method. So there we will be forcing the air, here we will be forcing what, water. So here the forced water flow is used to dissipate. See here, this is the water inlet, and here the tank oil will be there. The oil will be pumped to the heat exchanger. Here the heat exchanger, this the outer tube will be sprayed with water. So the oil is forced to flow through the heat exchanger with the help of the pump, where the heat is dissipated in the water which is coming through this inlet and which is going through the outlet. So here the cold water is taken through this inlet, and the hot water is sent out through this outlet. and this type of cooling is used in very large transformers, where it will be having the rating of several hundreds of MOU, sorry MVA,